Well, as engineers, we have come a long, long way in terms of thinking about reliability of our system. And reliability and security are both crucial for a trustworthy system. But building both reliability and security at scale is difficult because they do share common properties, many, many common properties, but also you need to think about different design considerations. So, when designing for security, we must assume that at any point an adversary could be trying to make things go wrong. And that's why we started to equip our engineers with an understanding of core security controls that need to be applicable. Which of these need to be turned on? Which of these need to be turned off? Let's take a look at the core areas. At a high level, business logic. The business logic is important because no service really operates in silo. So, making sure that our engineers and we understand the business logic and how can this be abused or misused is super critical. Second is what are we doing to enforce secure SDLC? Are there secure coding guidelines, checklists that are really accessible? Is there guidance that's accessible at any point during the process? What does the authentication and access control model look like? What's the input and output handling processing look like? What's the cryptographic usage for? Is there any implications? Are we thinking about crypto review here? And then data protection and privacy. That's also very important to consider what's the data classification for this service. And secrets handling, really understanding what are different secrets that I'm working with. What does that life cycle look like? How am I rotating, managing, handling my secrets? And last but not least, we're very good at auditing for performance, but what about security auditing? So that's another thing. So giving these core areas for our engineers has really helped us to bootstrap things without needing our intervention. And also, let's take a look at these core areas from the stride point of view. If we look at stride, spoofing, how does the component authenticates towards the service and resources? Tampering, does the component validate the message it receives? Repudiation, is the component logging the interactions in an audit log? Information disclosure, is the incoming and outgoing traffic encrypted? And what protocols and algorithms are allowed? Denial of service, is the component configured for high availability? Is it protected against DDoS? And also elevation of privilege. Are the users assigned the least privilege required? So really thinking about these core areas and thinking from a stride point of view has been really helpful when we are having the conversations.